Hi everyone, so in this video I'm going to be talking about multidimensional arrays, but before I do that, let me just show you something. Void foo, and this takes an integer array. So I'm just creating a function which I'm naming foo, and it takes an integer array as argument, and let's just do something like arr of 0 equals 0, and here let's just create an array int arr, let's say 4 again, and 10, 20, 30, 40. So if you remember, when we pass things to functions, the value of the actual variable was not changing. So let me just pass arr here to foo, and then print arr of 0. So let's just go ahead and print it out, arr of 0. And if the value of the original array does not change, that should mean that this printf will give me a 10. But if this actually changes the value of the original array, and I can actually just name this foo arr, and foo arr here as well, so that this and this are distinguishable. So this thing right here, let's see what it prints. So let's just do a gcc multidimensional arrays.c, and let me just leave this to a.out. I hope you've gotten into the practice of using the -o flag. So if I do an a here, as you can see, it prints out 0 here, which means that the value of the original array actually changed because of this function. And the reason for that is pretty simple actually. In the last video we saw that arr is actually the address of the 0 index element. So what I am passing actually is just the address. So whatever it's changing, it's actually changing at the original address. So that's one thing that I wanted to point out. And when we actually write functions related to arrays, we usually also give it the size of the array. So because this size is not going to be accessible here, and if we don't know what the size of the array is for the function, then we might want to take that as an argument too. So that's about passing arrays to functions. But let's now talk about multidimensional arrays. So the first thing to talk about is of course a two-dimensional array, and what we have talked about till now is as you might have guessed, a one-dimensional array. So let me just go ahead and create a two-dimensional array. The way to do that is just to add two square brackets here, and I can say that this array is a 4 cross 3. The first one is the number of rows, and this is the number of columns. And here if I want to take this input from the user, I'll have to do something like for int I equals 0, I less than 4, I plus plus, and here I'll have to run another for loop which is for int j equals 0. And always make sure that this variable name is different from this one, and we usually use things like I, j, k, l for our loop counters. These are known as loop counters because they keep account of the number of iterations that a loop has run for. So this is a j less than 3, j plus plus, and what we need to do here is a scanf and a %d, and here we'll have to give arr of I comma j. So that's how we write it, and let's just go ahead and try this out. So now it's actually waiting for me to give input. So I need to give this an input. Let's just give 1, 2, 3. Actually this doesn't make sense right now. Let me just also copy this loop and print it here. So let's just add a printf and say the array is and a \n, and instead of a scanf, let's just add a printf here. That actually reminds me that I should have an ampersand here, and let's just run this now. And now it's waiting for me to give input, and let's just give 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1, 2, 3 again. And as you can see, it prints out the array is 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. And if I want to actually print this array in a more beautiful manner, I should do something like a space here. And I just want to give a new line when it has printed out one row completely. So this inner loop is for printing out one row, and then it moves to the next row. So I should just have a printf \n here, and this should actually print the array in a prettier format. So let's just give it 4, 5, 6, 7, 8, 9, and 1, 2, 3 again. And as you can see, it printed out the array is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1, 2, 3. So that's about two-dimensional arrays. And let's just go ahead and comment this out. And I can actually just like one-dimensional arrays, give the elements here. They just need to be comma separated. So let's just do that. 9, 10, 11, 12, I think that's it. So let's go ahead and take a look at this, and as you can see, it printed out the values that I had given it. Also, in one-dimensional arrays, I told you that we could skip these when we just give the array here, and it's intelligent enough to figure that out itself. So let's try skipping these, and let's try compiling it again. And as you see, I've got an error here, and it says something like array type has incomplete element type or something. But basically the problem here, I think this should be pretty intuitive to you as well. Given numbers like these, and if I tell you that this is a matrix, the first question that you're going to ask me is what are the dimensions of the matrix, because if you have 12 elements, that could be a 6 cross 2, a 2 cross 6, a 3 cross 4, a 4 cross 3. That could actually be any of those. So both of these being blank doesn't work. So let's just give it a 4 here and try it now. And again it gave me an error, and this time you might say that given a 4 here, if I know that there are 4 rows, then I can actually figure out from these the number of columns that there are. But C doesn't work like that. You can't give it just the number of rows. Let's try giving it just the number of columns, and let's try it now, and this time it actually compiles correctly. So the way C works is you can give it just the number of columns, and it's fine with that. So what it'll do is put these in the first row, and then these in the second row, these in the third row, and so on. So that's something that you'll have to actually remember, and to be honest, I didn't remember this either. I just tried it with you. I just knew that it actually allows us to give just the number of rows or just the number of columns, but this is something that you should actually remember. Another thing that I want to talk about here is we've talked about a two-dimensional array, which is basically what we call a matrix in mathematics. But as you might know, computer memory is linear. So how actually does this array, how actually does the computer store an array? There are actually different ways to store it. It could store this 1, 2, 3 first, then this 4, 5, 6, then this 7, 8, 9, and then this 10, 11, 12. Or it might say that I want to store it column by column. So let me just go here and let's just type in A. So what it can do is store 1, then 2, then 3, then 4, then 5, then 6, and so on. Or it could say that I'll store a 1, a 4, a 7, a 10, then 2, then 5, then 8, then 11. So basically it can either store row wise or column wise, and that actually makes sense, right? If memory is linear, that's how you'd have to do it. And the way it's done in modern systems is row wise, and this method of storing, if you store it row wise, the method of storing is called row major, and if you store it column wise, that's known as a column major. So when we run a loop like this, versus if we run a loop like this, int I equals 0, I less than 3, I plus plus, and for int j equals 0, j less than 4, j plus plus, and here I do an ARR of j comma I. So this time I'm just accessing elements by the column, because when I is 0, remember that I'm actually accessing ARR of j comma I. So this 1 is my 0 comma 0, and then I'm incrementing the j. So what happens is now I'm accessing a 1 comma 0, which means that I'm accessing this one right here, the 4. So this one means that I'm accessing elements column by column, and this means that I'm accessing them row by row. And this is actually performance wise better, and although it doesn't make a huge difference, but this is actually related to CPU caching. By caching I mean CACHING. So this is actually related to that. So it's always better if the system stores elements in a row major format, then you should also try and access them row wise. But if you actually come across a system which stores array elements in a column major format, then you should actually prefer accessing them column by column. That'll be faster. So this is about two-dimensional arrays, and you can actually just extend this to multiple dimensions by adding as many brackets here as you want. Just remember to give these numbers right here, and preferably just give 1 in the first one as well. And remember that the number of elements that you need to have is this multiplied by this multiplied by this multiplied by this. So even if you have a three-dimensional array with a 3 3 3, that'll be 27 elements. So that's basically just a cube like thing. But also remember that in memory they're just stored linearly, and how three-dimensional arrays are stored, we won't get too much into that because it's quite a lot of mathematics. So I think that's enough for this video. I'll see you in the next one.